Good afternoon, sir.
Good afternoon to everyone. Good afternoon to everyone. In the last session, we have seen the fundamentals, basics, structured programming languages, non-structured programming languages, and the limitations in structured programming, and why do we need the object-oriented programming. In this session, theoretically, we focus on the fundamentals in object-oriented programming, and then right we focus on the structure of a C++ program. Then you see right how to program using a C++ language. I have shared the notepad, right? Please check if it is visible. Are you seeing the notepad?
Yes, sir.
Okay. So first, right, we finish the fundamentals in object-oriented programming, and then right we see the general structure of a C++ program, how to write a program in C++. This is the session objectives, right? Today's session objectives. We have seen in the last class, right? What is an object-oriented programming? Can anyone tell me, right? What is an object-oriented programming? What is an object-oriented programming? Anyone? Shamita?
Sir, objects are key concepts in object-oriented programming. Here we have two parts, data and function.
Yeah, data and functions. Okay. So we have seen good object-oriented program is one kind of problem-solving methodology. So to solve any real-world problem, we can apply object-oriented programming because this is similar to a structured or modular programming, but only the key concept is object. Object is the important key concept in object-oriented programming. Second thing, object-oriented programming modularizes your program. That means splits the program into two important parts. One is the data, and another one is the function. We have seen how the memory is allocated for the data and functions. Since data and functions are combined into a single encapsulated unit called a class. That means a class encapsulates data and function. A class can have several objects, and we have seen the important property of an object as the identity property. So, first concept, objects. What is an object? Object is a runtime entity. Objects are interests of users with respect to some point of view. Each object takes the space, that means memory, right? Each object takes the corresponding system memory. The important property of an object is identity property. Identity property distinguishes one object from another object, because data which is going to be accessed using the corresponding object, which is nothing but an attribute. Each object's attribute value need not be the same. It can have its own attribute values. But for behavior is concerned, a common behavior is going to be accessed by all objects. So we have concluded in the last session that data is concerned. Each object is occupying separate data because of its identity property. But for the method, function, or behavior is concerned, class functions occupy one-time memory which is shared for all objects of the same class type. For example, if we consider the class student, as we discussed earlier, having 50 objects, S1, S2, S3, etc., S50, and considering the student class, which consists of register number as attribute and display. What is display? Display as a function. In this case, having 50 objects for the student class, these 50 objects can have the rights to access the attribute using the dot operator. We have explored right further S1 dot say register number, this is equal to 100. Then S2's attribute S2 dot register number is equal to 101, etc. S50 dot register number is equal to say 150. In this case, the value of S1 dot register number need not be same as S2 dot register number. Then this need not be same as S3 dot register number, because each object attribute can take its own value. Because of this reason, memory is concerned. Separate memory is allocated for the attributes of the class. Keep in mind, this is the important point. Separate memory allocation for data and functions. This is the first point. Second point, separate memory allocation for individual objects of the same class. Individual objects of the same class. First one, separate memory allocation for data and functions of the same class, of course. Second one, separate memory allocation for the individual objects of the same class. So what do we mean? Memory allocation of an object S1. Suppose consider the address of S1 is 5000. Address of S2 is say 5006. Address of S3 is 5012. Individual objects are occupying different memory addresses. That is the meaning. Separate memory allocation is for the individual objects of the same class. We can ask a question, why S1 dot register number can take its own value. Since we know that register number is a primary key in the student information system, having one object S1. S1 is an object for, right, the first student. S2 is the object for the second student. Even we can write S2 dot register number is equal to 100. There is no error in that. But logically, object-oriented programming splits the attributes and the behaviors in different memory allocations or different memory locations. Further, attributes for the objects of the same class are also occupying distinct or different memory locations. So that's what, right, we have seen that the important property of an object is an identity property. Name must be a unique one, that is distinct names. In case, first if you define S1 as an object of student class in a C++ programming by writing student S1 semicolon. Second, if you write a student again S1, this results in error. Why? Object, right, should satisfy the identity property. Name of the individual objects must be completely distinct to one. So second, right, we can try student S2. The S2 is completely distinct from S1. Student S3. S3 is completely distinct from S1 and S2. Because of memory allocation is are also different for these objects. We need to follow the identity property. So objects are simply the user-defined entities or runtime entities. Objects are occupying space in the system memory. For one class, we can create several objects. Assuming student is the class, we can create several objects for the single class. Objects are responsible to access the attribute and functions. But functions are concerned, for example, as we discussed in the last class, in the student class, we like to define one behavior. The behavior is print the name of the student. Printing the name of the student is one activity behavior function. We like to call this function using the individual object. So when we call S1 dot behavior like this, later I will see the accessing rules of C++. So as of now, just think of, I am formally explaining S1 dot display. Then we call S2 dot display. In this case, we assumed that display is a common function which is used to print the value of a register number. So once you write a common instruction just to print the value of a register number, whoever can access the function display S1, S2, S3, etc., S50. When S1 is being called, right, or when the function is being called by the object S1, it is the responsibility of printing the value of S1's register number. When the function is being called by the second object S2, the role is to print the invoking calling object's register number. When S50 calls the function, say display, S50's register number is going to be printed. So the instruction print the invoking object register number is one instruction, or the function may take more than one instructions, more than one executable lines, whatever is, no problem. All these instructions are common to all objects of the same class. So the logical concept is, why should we go for the different memory allocations for the common function? Unnecessarily written, we should not have that one. So this is not necessary one. Logically, all of these common functions are going to be placed into a system memory one time. So that's what I said in the last class. Objects are concerned, right? Separate memory allocation for the individual objects. But for the class functions are concerned, each function is going to be placed into the system memory only one time, so that all objects are accessing, calling, invoking the same function. Understand or not? Having any queries? Please interact with me.
Sir, can you explain what is runtime entity?
Runtime entity, for example, in case, if you write student S1, next line you write student S2. So during the runtime, we are creating one entity, something interest with respect to our real world application. Take your student information processing is our real world application. With respect to that point of view, we are creating some entities, some user defined names. Simply user defined names. S1 is one name, S2 is another name, S3 is another name, S50 is another name. Clear?
Yes, sir.
Okay. Second class. What is a class? Class is also a user defined type. Class is a user defined type that encapsulates both data and functions. That means both attribute and behaviors into a single one. So why is it necessary, to combine data and functions into a single one means? Because the key concept in object-oriented programming is an object. Objects are responsible for accessing both the data and functions. Having several objects of the same class can access its own data and functions. So it is a right place for mix, wrap up, combine or encapsulate data and several functions into a single one, that is said to be a class. So in object-oriented programming, classes are also said to be ADTs. What is ADTs? In the last class I have said.
Abstract data types.
Yeah, very good. Abstract data types. For example, student is a class. We can define several operations, functions, behaviors which are going to be operated on the data of a class called student. So we can write get into calculate something, display or print details, etc. These are some of the operations, user-defined operations, just abstract operations, which are going to be operated on the individual data of the class. So classes are in general abstract data types that encapsulates both the data and functions. Class is in general a static concept because class statically combines data and functions into a single unit. But objects are concerned, objects are completely dynamic concepts. During the runtime, right, we can create objects. Here, class is concerned before the compile time, the code must be defined. That's what classes are said to be purely binding, or simply static concept. The objects are dynamic concepts. A class can have several objects. One class can define several objects. So who is responsible to access the data and the functions of the class? The kingmaker here is object. The object of the class can have the rights to access data and the functions. So later, we will see in C++ language how to define a class, how to define the object, the basic accessing rules of objects, classes in C++. So there, we will see constructing a class, constructing the object, calling a function, using the object like this. Object name dot, function name semicolon. How the object is responsible for sending and receiving messages. How one object interacts with another object, or simply saying how object communication is possible in object-oriented programming, right? So these are the things that we will explore with respect to C++ language. Hope you understand the second concept, class. Third concept is an abstraction. Abstraction, that you can say as the abstraction of a class, right? Abstraction, you are not providing in-depth implementation. Just you tell, what is actually going to be combined or encapsulated. So in this case, classes are said to be abstract data types because in C++, the abstraction looks like class, sample, within this opening and closing curly brace. Just I am formally explaining. Later we see the syntax of classes and objects. Here, for example, public, private, protected, say void, get input, void, process, something. So it seems that the class sample combines some functions. So of course, the data is missing. We can also write suppose int x, y, z. Data and functions are combined into a single unit class sample. So seeing this, we have only the abstraction. It does not reveal that how the class sample defines get input and process methods. So the complete implementation details are missing. Overall idea, seeing this right, what we can observe, sample is a class having some members, data members XY, the functions right get input and process. How the variables X and Y are going to be applied or processed inside get input and process. These are completely hidden, not known to the user. So in this case, abstraction provides the important rule. There are two kinds of abstraction. One is data abstraction. Second one is procedural abstraction. Data abstraction in the sense that seeing this right, we can conclude that int x comma y, something right variables are declared as integer x comma y. Or if I write the data a, b, sorry, h, something a, l. What can we observe from this? Some characters are returned. This is a conclusion. In case if I write 10, 23, minus 23, 45, 90, 0. What is the conclusion? Some integers are returned. Likewise, if I write something, right, fractional values, conclusion is some floating point numbers are returned. Or combining, right, this is a single one, some characters and integers are returned. This is data abstraction. So int x comma y simply shows the essential information without implementation. How x and y are going to be implemented in get input and the process are completely hidden, are not specified. So this is a data abstraction. And another one is a procedural abstraction. Or the procedural abstraction, right? You can say, right, some diagrammatic representation. For example, I am seeing the right the GCR page, right? So it shows that Ganga, Danya, Shamita, Roshni, right? Some of the students are attending this class. It shows me some student names. So this indicates that some of you are attending the classes. It does not reveal or show that how you are actually attending these classes. Understand or not? You are right listening the classes sincerely or simply right opening the right GCR and right seeing somewhere right not physically present. So this kind of things are completely hidden here. So in general, the same way object oriented programming, for example, here if I write void find, better example I tell you, square root, for example here I pass int x comma int y. So seeing this function declaration void find square root int x comma int y, it seems that square root function is going to be implemented here. It seems further find strroot is a function name. So we can interpret this as finding the square root of something. Or just to take right only one parameter for simplicity. So it clearly shows that square root of one parameter x is going to be computed in this function declaration. But this is the short idea, just abstraction. But this does not show how you are actually computing square root of x. Hope you understand. In-depth implementation of the data x is going to be hidden in this abstraction. That means in-depth implementation is completely not available, or we can say how square root of x is going to be computed. For that, right, we need a separate function, right, that can be defined even inside the class declaration or outside the scope of class declaration. That we will check later, right, using a C++ language. So as of now, classes are responsible for ADTs, abstract data types. So there are two kinds of abstraction. One is data abstraction, like this, variable declaration. And another one is a procedural abstraction, without implementing, right, the procedure, but we can say or we can conclude what is actually going to be implemented in that. What is actually going to be implemented in find str root, that is finding the square root. Only that abstract information is known to the user. When in-depth implementation is missing, that is a logical concept of classes supporting the abstract data types. Fourth one, encapsulation. Encapsulation, right, this is a way of combining the data and the functions into a single unit. In object-oriented programming, classes are responsible to combine the different attributes and behaviors into a single unit. So classes are satisfying the encapsulated things. Even in this, we can achieve the data hiding property. What data hiding property says? Private data is secured one. Or we can say private data is hidden from outside classes. So in this example, here by default, right, later with respect to C++, we can see by default, the class members are coming under the private section. So X, Y, even right, the member functions are all coming under a category private section, so that outside classes cannot enter into the class sample. So encapsulation, right, achieves the important property, data hiding a property, right? For example, you can write, just think of, right, how seeds are there inside the fruit, right? Simply write the fruit encapsulates the important part called seeds. So only the fruits can have the rights to access the seeds. Outside the scope of fruit, right, anything or nothing can access the inner part of the fruits. Same way, right, logical conclusion is defined in the object-oriented systems by satisfying the data hiding property. The fifth one, inheritance. Inheritance is the process by which one object acquires the properties of some other objects or several objects. In the object-oriented programming, there are different inheritances available. They are single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. These are the inheritances supported in object-oriented programming systems. In case of single inheritance, there is only one base class and one derived class. The derived class derives the features from the base class. Single, one base class. In multiple inheritance, there are more than one base classes from which the new class feature is going to be derived. For example, having the classes A, B, C, D, E, you can derive a new class here. That is multiple inheritance. Multi-level, more than one single inheritances. A to B, deriving the features from A to B, and deriving the features from B into C, and deriving the features of C into D. A to B, B to C, C to D. One example of a multi-level inheritance. Hierarchical, there is one base class. Different derived classes are going to be defined in the same level, like university system. Schools, below the class schools, you have the different schools, right? Say computing, then biotechnology, right? Electrical, like that. The different schools are at the same hierarchical level. Below the schools, right, you can have different departments. That defines the hierarchical aspect of a university system. Hybrid, multiple and hierarchical, right, can be combined to have, right, two or more inheritances can be combined to form a hybrid inheritance. So just to think, inheritance is one process using that one object can acquire access the properties of some other objects with respect to the same class. So later, right, you see how C++ defines, implements these inheritance types. And the sixth one, polymorphism. We are discussing the main topic, fundamentals in object-oriented programming, right? Objects, classes, abstraction, encapsulation, inheritance, polymorphism, right? These are the important concepts in object-oriented programming. Polymorphism. Poly, right, more than one, right, many. Morphism forms. So supporting more than one forms is a key concept in polymorphism. Normally, polymorphism is characterized by this phrase, one interface, multiple methods. Methods which are same as functions, right? Java professionally, right, we have the 10 functions, sorry, methods. C and C++, we have the term, right, behaviors, right, same as functions. Functions are same as written methods in Java. One interface, multiple methods. This is the key aspect of polymorphism. There are two kinds of polymorphism supported in C++. One is compile time polymorphism. Second one is runtime polymorphism. Compile time polymorphism, this is said to be purely binding. Runtime polymorphism, this is said to be late binding. To tell you, right, the best example of a polymorphism, how, right, one statement, that means one interface, works far differently in different situations. For example, I like to write, say the statement. My statement is, say, buy a ticket. This is my statement. Assuming that I am going to write, use the statement to you. For example, we are traveling in a bus. I am asking you, right? Simply, right? I say you buy a ticket. So what is the meaning? So I am instructing or simply right, I am asking something, right, at you. So you will be behaving accordingly, right? What will you do? You will buy a bus ticket with respect to the context. In case, right, if we are in the theater, if I ask you, right, simply, please buy a ticket. What will you do? You will get right a ticket for a film accordingly because there are assumed right we are in the theater. We are in the theater. Suppose we are in the railway station. I ask you right, same query, buy a ticket. I please buy a ticket. How will you right behave? You will be buying right accordingly the railway ticket. So if I say the query statement buy a ticket, common statement at different places, the role is right implementing the different operations. Here, of course, ticket is a common, right? A common, but it seems the operations may be a different one. We can implement the operations in a different way. So just think of right only one statement buy a ticket. This can be executing different operations at different situations. That is important one. So we can just think of buy a ticket is an interface, one executable statement. This one executable statement, or you can simply think of one function call. This function call executes the operations of different functions at different situations. That is the key concept. One interface, one executable statement calls the versions available in different classes, right? That we can see are the versions available in the same class, possibly. So there are two kinds of polymorphism, right? Compile time polymorphism, that is early binding. During the compilation time, right? Which method is going to be called? This determination is made. Runtime polymorphism, late binding. At a later time, during the runtime, the determination is made to call the right version of a member function or simply a function in C++. So this kind of polymorphic behaviors are supported in the object-oriented programming language called C++. Even right, you might have seen that the operator right plus is also a polymorphic operator. So if I write int a is equal to right 1 plus 2 semicolon plus serves us the role of adding two integers. In case if I write float x is equal to right 10.0 plus 2. Here 10.0 into 2 is converted into 2.0 and the floating point arithmetic is going to be carried out. So one operator, right, serves for different purposes. In Java, right, we can add, right, or we can have, right, plus to concatenate to two strings. String S1 is equal to hi in double quotes plus how are you in double quotes, semicolon. That plus serves string concatenation purpose. When the operands are integers, integer arithmetic, integer addition is carried out. When the operands are right string types, string concatenation is going to be carried out. So based on the operands, based on the context, bus, right, station, somewhere, right? So based on the context, you are right executing the task accordingly. Same way, one executable statement can call the versions available in or can call the different versions available in same class or different classes. That is the logic of a polymorphism. In C++, function overloading, operator overloading are the examples of compile time polymorphism. Function overloading, operator overloading. These are the examples of compile time polymorphism. For example, in the student class, assuming that S1 is one object, S2 is another object, S3 is another object. Having these three objects, assuming S1 and S2 have the register number, or simply write one integer variable, say x, S1 dot x is 100, S2 dot x is 200. If I write S3 is equal to S1 plus S2, what is the meaning? S1 and S2 are objects. You cannot directly add two objects in such a way that the contents of S1 and S2 are going to be added. So S1 sex is 100, S2 sex is 200. Assuming that S3 sex is 100 plus 200, 300. If you write S3 is equal to S1 plus S2, this will not work. S3 sex will not be 300. S3 is equal to S1 plus S2 will not add the contents of the objects accordingly. S1 x with S2 x, S1 y with S2 y, S1 z with S2 z. This is not possible. But here, using some specific task that is going to be defined to the operator plus, so that when you give a special significant to add two objects using the plus operator accordingly, having that definition, then the statement S3 is equal to S1 plus S2 semicolon will add the content of two objects S1 and S2, and the result is going to be updated in the third object S3. So just to think of, later we will explore operator overloading, function overloading. So as of now, just to think of buy a ticket, an example of function overloading, right? S3 is equal to S1 plus S2 and A is equal to 1 plus 2. This is an example of operator overloading. Writing int A is equal to 1 plus 2. Integer addition is carried out on the appearance of type integer 1 and 2. S3 is equal to S1 plus S2. Object addition is carried out because the operands are of type objects, provided that you should have the definition of operator plus in your program. So one operator can be used for different purposes: adding integer types, adding floating point types, or concatenating strings, or updating the relevant contents of the objects. Right? For example, plus is concerned. So this is an example of polymorphism. Two kinds of polymorphism: runtime polymorphism and compile time polymorphism. Runtime polymorphism is implemented with the help of virtual functions. We see later, again using the concept of pointers, base class object pointer, derived class object pointer. We'll explain later when we discuss the runtime polymorphism. As of now, just think of C++ supports these kinds of polymorphism: compile time and runtime. Seventh one, message communication. That means message passing. In object-oriented programming, objects are responsible for calling the variables or functions. So in this case, we have two objects, object 1, object 2. Two objects can interact each other. Objects interact each other by sending and receiving messages. How the messages are going to be sent and received. This is important. In C language, you might have seen, for example, this is a main function. Main function is calling a function. For example, here float something x is equal to, or x is a floating point variable already defined. X is equal to average of some numbers, say 1, 2, 3, 5, something. 4 numbers are passed as the parameter, actual parameters to the average. Here the function average is returned, for example, with some variable declarations. I am missing here. Formal parameters I am missing. Here something, right? Return type is say float. Having some statements, executable statements here. Finally, one return statement is there. Return something AVG. Assuming right AVG is a variable, which returns the average of the actual or even right the formal parameters, two formal parameters. Indirectly, message communication is possible in C++ because the main function passes these parameter values to the function definition as messages. Hope you understand. Average is a function. To this function average, the main function passes some parameters, variables, values, whatever it is. Those are messages. Clearly, the function definition receives those messages and try to send one value to the calling place, say AVG. While the function is trying to send one value to the function call, you need to think of this as returning some value to the calling place, same as sending some message from the function definition to the function call. Hope you understand. So in C++, a function may take parameters that can be passed as parameters to the function definition. Function definition may process something based on the parameters. It may return a value to the calling place. So it may return value, right? Normally function returns one value, right? In terms of structure, right? Multiple values. So just think of anyhow, one value is returned to the calling place, similar to a message. In the same way, in object-oriented programming, how this message communication is established. Message communication is established using the objects. So objects are here responsible for sending and receiving messages. As we have seen earlier, for example here, s1.display. What is s1.display? S1 is an object, display is a function name. The object S1 tries to send 0 message to a function display because here the actual parameter is empty. Suppose it sends a message, for example, s1.display 100. Assuming that 100 is received in the function definition, for example, I mean 100 times you want to display the value of S1's register number using some for loop. So that stage, right, you can just think of the value 100 is sent from the function call to the function definition in terms of a message. So who is the caller? Who invokes the function display? S1 is a caller. S1 is a calling object. S1 is the invoking object. All terms are synonymous. Invoking object, calling object, caller, and the callee, right, display, right, a function that is going to be called. The function display receives a value 100. Who sends a value 100? Calling statement. Who is actually the calling statement for the S1 invokes the statement, invokes the function display by sending a value 100. So S1 sends a message 100 to a function display. Who is S1? S1 is an object. So object is responsible for sending a message in terms of values to the function. In turn, right, in return, right, a function display may process a value 100. It may return some value to the calling function. That's why, right, you need to think of the function is returning a value to a calling place. That means the function sends another message to a calling state. So functions, right? Just to think of simply a function, but actually that function is invoked by the calling object. That don't think that function is returning a value to a calling place, but actually function is returning a value to a calling place. But since that function is invoked by some object, the logical concept is object is actually sending a message from the function to the calling statement. Hope you understand. So that's what here I said that in the object-oriented programming system, objects are responsible for sending messages as well as receiving messages. Right? So when the object, one object is sending a message from a function definition to this calling statement, that object is responsible. Likewise, here from the calling statement to the function definition, some values are passed means that is possible only with the help of object. Say S1 dot, S1 plays a role. Likewise, from the function return, invoking object or some other object is responsible to return a value, to send a value from a function definition to the calling place. Hope you understand. So in the object-oriented system, message communication is possible, right? So other than this, dynamic binding is possible. That means the code associated for a function call can only be known at a runtime, not at a compile time. So better example, right? The runtime polymorphism that we will discuss later when we discuss the concept of inheritance. Runtime polymorphism, that means a dynamic dispatch. The code associated for function call is known only at runtime. So during the runtime only which function is actually being called is known. In case if it is known before the runtime, that should be a compile time polymorphism like function overloading and operator overloading. So at the end, right, we will right implement runtime polymorphism with the help of inheritance and object pointers. So in this session, right, we have discussed the fundamental concepts in object-oriented programming. Concepts are objects, classes, abstraction, encapsulation, inheritance, polymorphism, message passing or message communication, dynamic dispatch or runtime polymorphism. With respect to these, we can say C++ is said to be a partially object-oriented programming language because you can write a C++ program similar to a C program without applying the concept of classes and objects. Where Java is said to be the fully object-oriented programming language, there you need at least the concept of class, right? So with this, let us wind up the session So I ask you to recall yesterday's session and today's session. So you please go through these fundamental concepts, right? And learn, right, these things. What are objects, classes, right? Abstraction, encapsulation, inheritance, polymorphism, message communication, dynamic binding, or runtime polymorphism. So this is our right from 2 to 3. I ask you right to go through these fundamentals. In the coming sessions, we will directly enter into the C++ environment so that right we will solve right some problems. When you compare the next week, right, the same session, Wednesday session, you will be able to solve the problems using C++ programming. Understand? If you have any queries, you can ask. I post this material now. In this session, please go through this material and try to learn these fundamentals in object-oriented programming carefully. So with this, right, let me wind up this session.